Right, hi everyone. Welcome back to Grade 12 Maths with Mr. Simons, where we make maths simple and get you to be exam ready. Right, today's video or lesson we will be introducing you to contingency tables, which forms part of probability. Right. So before we go further, let's show you what a contingency table looks like and what's the purpose of it. Right. So a contingency table, also known as a two-way table, or cross-tabulation or cross-tab. It's a table that simply displays the frequency distribution of two or more categorical variables, right? So there, if you look, there's an example of a contingency table. We have males, we have females, we have total. But at the same time, we have those that like broadcasting and those that did not like the broadcasting. Right, so there, as you can see, it helps analyzing the relationship between these categorical variables by showing how often specific combination of categories occur. Right, so we can say here from the table there are 60 males that like broadcasting, but there are 70 females that like the broadcasting. So in total 130 people like the broadcasting. Right, if you look again here for male, there the total is 150, 150 minus 60, 90. So 90 males did not like the broadcasting, while 30 females did not like the broadcasting, right? And if we say 90 plus 30, that would give me 120. Right, so hope you understand, you follow. Right, so analyzing these relationships, contingency tables are primarily used to determine if there's any association or dependence between these variables. So we can check whether male and liking the broadcasting is independent or dependent of each other. Events, right, and the visual representation of this data makes it easy for us to look and identify our patterns and trends. So that's what it looks like. In the next slide, I'm going to do a small example before we go to the real exam question. So if you've played Sudoku before, this shouldn't really be a problem. And if you solve probability before, the probability itself is also not difficult. Right, but yeah, let's look at an example of a contingency table and a question or some questions on it. Right, so calculating probability. So here they say a survey concerning their holiday preference was done with 180 staff members. The options chosen and the frequency of results is noted in the table below. So there, if we look at male, 46 of them prefer to go to the coast, 24 of them want to go to the game park, and 13 of them want to stay home. How boring, but yeah, they want to stay home. The females, 52, want to go to the coast. I assume that's the 52 that's in the gym regularly and just want to go get some vitamin D there from the sun. The coast. We have females, 38 females that want to go to the game park. And we have 7 females that want to stay home. And these, I assume they enjoy reading a book. These, I assume, are more adventurous that want to go to a game park. In total, we have 97 females interviewed. So more females than males have participated in the data or the survey, whichever way you want to look at it. Right, so question 1, determine the probability that a randomly selected staff member of the 180 is male. 1.2 is at home for the holidays. Is a female and wants to visit a game park. Is a male and visit the coast. Right, and then question 2, are the events being a male and staying at home? Independent events. Motivate your answer with relevant calculations. Right, so this year should have been done with you in grade 11. If you want to and you feel you need more help or more details, we've done extra work for you on my grade 11 channel, grade 11 maths with Mr. Simons. Right, so let's answer these questions. So determine the probability. 1.1 is male. So if we look at the male row, if we go right across, there are 83 males in total. So probability you'll be a male would be 83 over the grand total of 180 staff members. So of the 180 staff members, 83 are male. Can simplify that, or we can write it as a decimal. We can even write it as a percentage. No? So you can go write that as 46%, but as a decimal it becomes 0.46. Probability you're home, right? So how many people are staying home out of the 180? 20. So 20 in total out of the 180 want to stay home. That simplifies to 1 over 9. If I use my calculator, 1 divided by 9 would give me 0.11. Right? 1.3 is a female and visits the game park. So now we're looking collectively at two events. Right? So we have female, there's female, and we want game park. So game park and female meets at this point where it's 38. So females that want to go to the game park are 38. So therefore 38 out of 180, or we simplify 19 over 90. Of the females want to go to the, are female and want to go to the game park. Are male and want to visit the coast. A lot of males love the coast, right? Some enjoy fishing, right? Others just enjoy the sun and the scenery. Like myself, I enjoy just going to Cape Town and Blouberg Strand and watching Table Mountain. It's a beautiful sight. So probability of male and the coast, right? So there, male and coast, we have male and coast, they meet there. So therefore 46 out of that 180 equal 23 over 90. Right? And please don't go make the error. So there, when I say probability male, learners would go right the 83, they understand it's 180. But once I combine and say female and game park, you some decide now that it's female and game park would be 38 out of 97, or others go right 38 over 62. So here we are dealing with a probability. Selected staff members, we have 180. Alright, so we have 180 staff members, therefore that probabilities are all over 180. Alright, now question that we will always ask with the contingency table or the two-way table are events of being a male, staying at home, independent. Motivate your answer with relevant calculations. So being a male and being at home must equal probability of being a male times the probability of being a home. Alright, so this must always be the case. You see, probability male and home must equal the probability of male times the probability of home. So we use the product rule. So being a male and staying home is, from there on the top, we had 13 over 180. So there we have 13 over 180 of males that want to be home. Right? Probability of male, 83 over 180, which gives me 0.46. Probability you want to stay home, equal 20 over 180, which equals 0.111. If we multiply now 0.46 times 0.11, gives me 0.0506. At the same time, 13 over 180 would give me 0.072. So these two values are not equal to each other, so therefore they are not independent, but they are dependent events. Right, so I hope you follow. So whenever we say are they independent or not, so there you see being male, the key word in between is and. Being male and staying home must equal probability of male on its own times the probability of staying home on its own. If that's the case, then we say it's independent. The two are not equal, they are dependent events. Now, if you found this lesson helpful or you enjoyed the video, hit like and subscribe, right, so that we can ensure you are in line or don't miss the next lesson that I will be uploading. So I'm going to try to upload at least 2 to 4 lessons every week. And that's for grade 10, 11, and 12, right? Continue practicing. I wish you nothing but the best. In the next lesson, I'm going to specifically look at some past exam questions so you get used to solving this, right? Right, you can pause the video here. You can look at the table, read through it, solve, right? I will be uploading some extra resources, PDF resources for you that you can use to practice from. All right? Wish you nothing but the best. God bless. Bye.